Hi folks, today we're looking at combining transformations. So that means putting our stretches, our reflections, and our translations all together. So it works this way. We've already seen what happens if you have a number in front of the whole function. This gives us our vertical stretch factor. So this would be vertical stretch by a factor of the absolute value of a, because we always want to say a positive scale factor. If a is negative, then we have an x-axis reflection, or reflection through the x-axis. Now we get to the coefficient of x, which is b over here. And these letters are all arbitrary. We could use different letters to represent them. It's all about where they are in the form. So this one is a coefficient of x. Notice it's factored out. This is going to give us our horizontal stretch factor. So this will be horizontal stretch by a factor of the reciprocal of b. And again, we'll use those absolute value brackets. If you have a negative b, that means we have a y-axis reflection, or reflection through the y-axis. If we have one of these x minus h thingies, that means that we have a horizontal translation, or shift. And just to recap, x minus 2 means to the right 2. Lastly, we might be looking at this k value at the end. So this is going to give us our vertical translation, or lift. Okay, and if you had plus 2, that would mean up 2. If you have it in this form, where the coefficient of x is all factored out, and where we have it in y equals, we translate last. It does not matter which order we stretch and reflect in, but it does matter that we translate or shift last. The general mapping rule that we get from this is as follows. Any point xy is going to be transformed, where you go 1 over b times the x value, because that'll be our horizontal stretch factor, plus h. Now check it out over here. It's in this x minus h form. And the y value will be ay, because we're multiplying by the vertical stretch factor. And then the k will make a difference. You can memorize that or not. Either way, we can probably generate a good map. So with that in mind, let's make sure that we've got stuff in the correct form. If I take a look at these two examples, we really want to get stuff in this kind of form. And over here, I've got a problem. I've got y plus 3 on one side. So what am I going to do? I'm just going to move stuff over. I'm going to move that 3 over, and I have 2f of 5 brackets x plus 1, and then minus 3 at the end. And that tells us all about our different transformations. That 2 out front means a vertical stretch by a factor of 2. And if it were the final exam, we'd probably write by a factor or by a scale factor. I'm just doing it quickly, so I'm writing multiplication. We've got a horizontal stretch by a factor of 1/5. We're moving left 1, and we're moving down 3. Okay? Those are our translations. If you wanted to turn that into a mapping rule, here's what it would be. We've got a horizontal stretch by a factor of 1/5, so it's 1/5 times x. We're moving left 1, so we'd subtract 1. We've got vertical stretch by a factor of 2, so that's our y times 2, and we're moving down 3. That would be the mapping rule that moves any point from the original function f of x onto this newly transformed function. Now, some people are going to get annoyed probably at this minus 1 because it looked like a plus 1 over here. But remember that x plus 1 means left 1 unit, so it's going to have the effect on a point that the x value decreases by 1. You could also have thought of this x plus 1 as x minus negative 1, if that helps. All right, the next one. We want to make sure it's in the correct form, and it almost looks perfect, right? It's got this 4f of 5x minus 15. The only thing to notice here is that to get this translate last property, we need the coefficient of x to be factored. So I'm going to rewrite this. That 5 needs to be factored out from x. Now what's that going to do to this whole binomial? Well, it will turn it to 5 bracket x minus 3 plus 2. In terms of a correct order and the correct transformations, I can write the stretches in any order. So it's vertical stretch, x4. It's horizontal stretch by a factor of 1/5. Okay. And from this form, it's then translated. And same thing with the last one we did. It would be then the translations happen. 3 right and 2 up. Okay. So it initially looked like it was moving 15 to the right. When we factor it correctly and do our translations at the end, it's actually just 3 right. You can also take it from the given form and do it in a different order, but it's typically not a great idea. This is the ideal form, this factoring out the coefficient of x. As a map, what would that tell us to do? It would tell us to multiply our x value by 1/5, and it would tell us to move to the right 3, so that's going to add 3 to our x value. For the y's, we're going to multiply it by 4 because of a vertical stretch by a factor of 4, and we're going to go up 2. Let's put this to use in some kind of a function. So here we're going to think f of x is just a basic cubic. I'm going to draw it over here. Basic f of x looks like this. It has 1, 1, has 0, 0, has negative 1, negative 1. There's f of x. If I have f of 1/4 x, that is going to be a horizontal stretch by a factor of 4. So I'm just going to take all the key points from the original one and move them around so that I get a horizontal stretch by a factor of 4. Some people are going to feel comfortable doing this just by inspection. So they'll go, the origin, if I stretch it horizontally, doesn't change. The point 1, 1 will just be 4 times as wide. That puts it over here. The point negative 1, negative 1 will be 4 times as wide. That puts it right here. Okay. So now we really do have that green shape, but just kind of stretched out horizontally. If you don't want to do that, if you want to show some sort of method, maybe what you'll do is generate a map. And that map will show the horizontal stretch. The x's are getting times by 4, and nothing's happening to the y. And then you'll just apply that to the key points that were on your basic cubic, the points that we knew were on f of x. So that would be the point 1, 1, 0, 0, and negative 1, negative 1. And that would give us outputs of 4, 1, 0, 0, and negative 4, negative 1, which are exactly the points that we did by inspection already. Either method is fine, but when stuff gets rough, you may want to go for the map. All right, let's try another one. So over here, we've got a vertical stretch by a factor of 2, followed by going left 4 and up 3. So this may be harder to do just by inspection. Here, maybe I'll generate the map to start myself off. So xy is going to be turned into, going to move left 4, so that's subtract 4 from x. Vertical stretch by a factor of 2, so I times my y by 2. And I move up 3. The key points that are on the basic function were these 3. So I'll move them around. 1 minus 4 is negative 3. 2 times 1 plus 3 is 5. For 0, 0, I'll get negative 4 and 3. And for negative 1, I'm going to get -5 and +1. Once I have that, I can generate my graph. So -1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so -3, -5 was one of them. -4, +3 was another. And -5, 1. Here we go. Now notice the middle one would be kind of Travolta's neck. So it's where we have that inflection point. And there's our general look. We've got a few key points. And we have a nice looking graph. All right, very last one. We've got f of 2x minus 4. So in this case, it is not quite in our preferred form. We want to have the coefficient of x factored. And once we have it like that, we're going to know that we have a horizontal stretch by a factor of 1/2. And we're also moving right 2. Again, I think I'm going to map this one. So any point xy is going to be transformed by timesing the x by 1/2 and adding 2. Nothing's going to happen to the y because there are no vertical transformations. I'll do that to a few key points, and it will give me a good version of the graph. So 1/2 plus 2 is 2.5, 1. 0 plus 2 is 2, 0. And -1/2 plus 2 is 1.5, -1. At this point, we can make the graph. Let's keep this in black for now, and now move to blue. So 2, 0 is sort of Travolta's neck. This point right here, 2.5, 1, is going to be another key point. You can also just use tables of values. And 1.5, -1 is right here. Okay, another key point. So it does look like it's smushed in horizontally. And it also looks like it's moved to the right too. That gets us through the basics of being able to combine some transformations. We'll look at this in greater detail in class, but I did want to make sure that we had a little bit of exposure to the idea that these transformations can be combined, and that this is what each of the parameters do to the graph, so that we can make it fit maybe some data or think about an exploration topic for the future. Take care, folks.